Hello everyone, welcome to this class. In today's class, we'll be discussing problems on mechanical properties of solids. Already we have learned all the concepts of mechanical properties of solid. We have learned about Young's modulus, bulk modulus and shear modulus. Today's class will be seeing various questions based upon JEE main exercise that is asked in the JEE main examination. The question will be single choice and each question will be having one correct as the right answer. Now let us go with the first question of the day. First question, the graph shows the extension delta L of a wire of length 1 meter. So we have a wire of length 1 meter, that is what has been provided in the question. So I am underlining this first important thing. Suspended from the top of a roof at one end and with a load W connected to the other end. That means the wire is connected at top and a load is connected at the other end, that is at the bottom end of the wire. If the cross-sectional area of the wire is 10 to power minus 6 square meter, this is the area of cross-section of the wire that has been provided in the given information. Calculate the Young's modulus of the material of the wire. So we have this graph given for delta L into 10 to power minus 4 meter, that means delta L is given in terms of into 10 to power minus 4 meter. Now here at the x-axis we have the load that has been suspended from the bottom end of the rod. We can see that it's a straight line curve. It's a straight line curve. Next, the options for the Young's modulus are 2 into 10 to power 11 Newton per square meter, 2 into 10 to power 10 Newton per square meter, third 3 into 10 to power 12 Newton per square meter, and D 2 into 10 to power 13 Newton per square meter. Now I believe that you must be remembering the formula for Young's modulus. The formula looks something like this. I have told you in class about the Young's modulus. Y is equal to F by A delta L by L. This is what we have taken down as the formula for Young's modulus. This is stress F by A. This is the strain delta L by L. Now if we simplify this, we will be having F we can write as the load that has been suspended. You can see it is given in terms of W in newtons. So we can actually change this F as W. Then we are having delta L, W by delta L. This L will move up, we will be having L by A. Now see we have here W by delta L. Now this is L by A, L is provided, A is provided, and we are also given W and delta L. Now see here for various delta L, W is also provided. So can we go ahead and can we put up the values for any value of delta L with respect to the any value of W? We can put and we can get the value. You can see a delta L for the value 4 into 10 to the power minus 4, we have W as 80. So we can put and we can get the value of Young's modulus, and rest of the things will automatically take care of. You have L by A also you have been provided. L by A, L is, you see L is 1 meter, A is 10 to the power minus 6 square meter. So if I go ahead, if I put all the values, this is 1, this is 10 to the power minus 6. For a particular value, can we put W as 80 and L as 4 into 10 to the power minus 4? So let me put here W as 80 and delta L as 4 into 10 to the power minus 4. With proper units I have put, so need not to, everything will be in SI units. Now you see here, since delta L versus meter, so I have put in length is in meters, I have put here. Area is 10 to the power minus 6 square meter, again that is in SI units. W is 80, that I have put here W as 80, and delta L as 4 into 10 to the power minus 4, 4 into 10 to the power minus 4 square, sorry, it's in meter. Now you see here, can we simplify this? We will be obtaining the answer 4, this will go 20 times, and we will be obtaining 10 to the power minus 4, 10 to the power minus 6, that will give us 10 to the power minus 10, it will move up, you will be having 10 to the power 11, so sorry 10 to the power 10 will go in the positive, so 2 into 10 to the power 11 Newton per square meter, that will be the result. 2 into 10 to the power 11 Newton per square meter. Let's check the answer. First option 2 into 10 to the power 11 Newton per square meter, that correctly matches. Rest of the answer 2 into 10 to the power 10 incorrect, 3 into 10 to the power 12 incorrect, 2 into 10 to the power 13 incorrect, only this one is correct, 2 into 10 to the power 11 Newton per square meter. So this is how we can obtain when we are provided with a graph, or it is an easy question. We have to put up the formula, we have to check for the given graph how to put up the values. We saw that delta L at a particular value of load suspended, we have its value put the value in the given equation, you will get the required result. This is how you can solve. Let's proceed with the next question of the day. I hope that you find it easy solving such questions. Now, in your JEE main examination, question based upon mechanical properties of solid, Young's modulus or bulk modulus, that will be not too tough. If you know the formula, if you know the basics, you can easily solve them, as we have seen just now. Let's go to the next question. Second question. The following 4 wires of length L. So we have provided 4 wire dimensions are provided of length L. You see, length L are different in each of the cases. This is L, capital L, and radius R are made of the same material. This is radius R of the same material. Which of these will have the largest extension? You try to understand here that you are having lengths are provided, the radius are also provided for each of the wires. Which of these will have the largest extension when the same tension is applied? We have to check here which of this will have the largest extension. That is the delta L we need to identify. Young's modulus remain constant since the material is same. You see here, length L and radius are of the same material. If the material is same, that means Young's modulus will be same for each of the wire. The dimensions are different, length and radius are different, that means length will be different and area of cross section will be different. So let me write down the formula for Young's modulus. Young's modulus is Y equals to F by A delta L by L. This is what we have. Now it says that when the same tension is applied, which of these will have the largest extensions? We need to talk about delta L. So delta L, if I make as subject, we will be having F L divided by Y A. This will be the formula for delta L. Now F is what? F is the tension that we have applied, and F is same for each of the wire. Why? Because the material is same. I have told you in the class, for the same material, the Young's modulus will remain same. It doesn't matter what is the length, what is the area of cross section. Now we have to talk about extension in each of the wire. Now extension directly depends upon length divided by area. Force and Y are constant, F and Y are constant, so it will be directly proportional to ratio of length and area. So if we find out the ratio of length and area will get in which we will be having the maximum extension. Let's try to calculate first length and area, that is the ratio, and before that area is what? Pi r square, pi is again constant. So delta L will be proportional to L divided by R square. Since area is pi r square, so we can write delta is proportional to L by R square. Now here capital is given as 50 and R is 0.25 mm. All are in same units. So we need not to consider to change the units. We will just do L upon R square for each of the given wires. So first we have 50, we have R 0.25. So for wire 1, let's quickly evaluate for L1 by R1 square. So 50 by 0.25 whole square. Let's evaluate this. 50 upon 0.25 whole square. 0.25, 25 whole square, that is 625. So this will turn out to be 50 divided by, now see 25, that we can write as 25 into 10 to the power minus 2. So that will be written as 25 into 10 to the power minus 2, so 25 whole square, 625 into 10 to the power minus 4. This is what we can write. Again, we can easily simplify this. You will be obtaining, if you simplify this, you will be getting 2 divided by 25 into 10 to the power 4. You can write this. I am just using the ratio. Units we are not concerned because for all the 4 wires, the units are same. Let's go to for wire 2. For wire 2, length is given as delta L we need to talk about. So let me take the ratios of L2 upon R2 whole square. See what this will turn out to be. L2 that is given as 100 and R is given as 0.5. You can check the given data. This is 100, this is 0.5. Let's quickly estimate it. 100 divided by 0.5, so 5 into 10 to the power minus 1 whole square. See here, if you solve this, you will be getting 100 divided by 25, that will be 4 into 10 to power minus 2. So this will be 4 into 10 to power 2 we got for the second wire. Now for the third wire, you see here, wire 3. Let's try to estimate the third for wire 3, the ratio L3 by R3 whole square. Let's try to obtain this. See here, L for the third wire is given as 200 centimeter and radius is given as 1 mm. Let's try to solve it. For the wire 3, L3 by R3 whole square, we are provided with 200 centimeter, that is what the data has been provided, and R is 1 mm. So need not to change the unit, we are using for each of the wire radius as 1 in mm, so need not to change the unit. So we will be having this as 200. This is equal to 400. For simplicity, we can write this as 400 for the wire 4. Fourth wire, again L4 divided by R4 whole square. Let's quickly check the data for the wire 4. Length is given as 300 centimeter, that you can easily observe. 300 centimeter and 1.5 mm is the radius. Let's go ahead and quickly solve it. 300 divided by 1.5 whole square. Now quickly we can solve 1.5, you can write it as 1.5 into 10 to the power minus 1. So 15 into 15 into 10 to the power minus 2. You see here, this will go 20 times. 15 into 30, that will go 20 times. 20 by 15 will give you 4 by 3 into 10 to the power 2. So this will be 4 by 3 is 1.33. So you can write approximately 133. Compare. Wire 2 is more than wire 3 and again it is more than wire 4. So comparing wire 2, wire 3 and wire 4, we have wire 2 is larger. Now for wire 1 and wire 2, you will see this is 2 into 10 to the power 4 divided by 25. If I solve this, we will be having 200 by 25, 800. Maximum for wire 1, that is the ratio L1, L by R square, that is maximum for wire 1. Now quickly you see here, quickly see the question. Option number A, when you are having maximum, that means you have, this is the right answer, the extension in wire 1 will be maximum. So for such question, for each of the given dimension, you have to check individually which one will be having the maximum extension by going on with this method. I hope that you have understood how to solve this. Let's go ahead quickly with the next question, and prior to that, just let me clear the board for you all. I hope that you are learning simultaneously in the best way and you're understanding how all the concepts you have learned in the class can be applied here for the given set of questions. And let me tell you, straight questions are asked in this chapter in your JEE main examination. 1 or 2 questions you can get based upon Young's modulus or bulk modulus in your examination. Now after question number 2, let's switch to the question number 3. We have the question reads as, the graph shown was obtained from the experimental measurements of the period of oscillation T for different masses M placed in the scale pan on the lower end of the spring balance. The most likely reason for the line not passing through the origin is that A. Spring did not obey Hooke's law. B. Amplitude of oscillation was too large. C. Clock used needed regulation. D. Mass of the pan was not neglected. Now see here, we have a graph given with T square and M. We have been provided with a graph given a straight line that is not passing through the origin. T square is already proportional to M, but that is not passing through origin. This is what has been provided. Now try to understand how to understand such question. First of all, as per the given graph, one thing you can identify, when the mass is made 0, when the load that you are suspending in the pan, if that is made 0, time period is still shown because some certain value we have for load 0. So I am writing here the first information for load equals to 0, time period is still present. When time period is present, that means still the spring is oscillating. Still the spring is oscillating. So first of all, you see here, read this statement, spring did not obey Hooke's law. We cannot identify this one. So this option will be incorrect. Amplitude of oscillation was too large. It doesn't matter, nothing has been given for the amplitude. Don't worry about this, incorrect. Clock use needed regulation, you cannot comment on this. Clock used needed regulation, leave it. Force and mass of the pan was not neglected. Yes, because when you did the load 0, still spring was oscillated because there was a pan on which you were keeping the load. That mass was also acting, and due to that only time period was occurring. Still spring was oscillating. Hence, mass of the pan was not neglected. This is the right answer, option number D. Theoretical question, but quite good for our building up concepts in this topic. So I believe that you have understood what this question was demanding from us. Next question, let's go ahead with the next question of the day. Fourth one, two wires of equal length and cross section area. We have two wires, equal length and equal cross section area, suspended as shown in figure. You have this figure. Their Young's modulus are y1 and y2. The equivalent Young's modulus will be A y1 plus y2, B y1 plus y2 by 2, C y1 y2 upon y1 plus y2 under root y1 y2. Now see, as per the given figure, you see here it's given that both are having the same length L and L, both are having the same cross section area A and A, but the difference is in the Young's modulus, that is y1 and y2 is the Young's modulus of both the wire. Let's say the load is here of mass m. This is what has been shown. Now see that a wire will also behave as a spring. If it is extended, it will try to reach to, when you remove the load, it will try to come back to its original length. That means we can use the concept of spring constant in this particular scenario. Now see here, in case of spring constant, if I talk about, we know that F is equal to Kx, so we can straightway write spring constant K is equal to F by delta L. This is what we can write for spring constant K equals to F by delta L. Now I will show you the figure separately so that you can identify how to proceed. This was the case provided. There were two wires hanging and we have a load here. We have a load here which was hanging due to both the wires, due to connection with both the wires. This was a load which was hanging. As per the given identification, we have y1 and y2. Length and area were same, L and A, L and A. If we combine this, if we combine both the wires, what we will be having? If we combine both the wires, we will be having this scenario as I am going to represent. One wire is hanging here, one wire is hanging here. They both are attached, and again there's a load connected, the same load is connected. This will be having the same length L, but the area will be now 2A. We need to identify what is the Young's modulus. Let's say Y is the Young's modulus. Now see here, K is F upon delta L. K is F upon delta L. We know that Y is equal to F divided by A delta L by L. This is what we know. Load is same in both the wires. Now how we can identify? We want F upon delta L. So F upon delta L can be written as, this will go up, Y into A divided by L. We can write F upon delta L is equals to YA divided by L. This we can write. Now you see here, both these wires, if you know for spring, if the springs are connected in parallel, the equivalent spring constant is the sum of the individual spring constant. What I mean to say, if each of these are having spring constant K1 and K2 and this is having spring constant K, so we know that for parallel connection of wire, for parallel connection of spring, we know that equivalent spring constant is sum of individual spring constant, and if they are connected in series, then 1 upon k is equal to 1 upon k1 plus 1 upon k2. This correction is shown in parallel. Now let's go ahead. We have this k. Now see, k is proportional to f upon delta L. You can see here, and f upon delta L is ya upon L. So let me write here y 2a divided by L and k1 as y1 into a divided by L. That is L is same. So let me keep here same L plus y2 into a divided by L we have here. If we simplify this, this is a will be cancelled out for each of the term, L will be cancelled out. We will be having y is equal to y1 plus y2 divided by 2. Easily you can identify y equals to y1 plus y2 by 2. This is how you have to proceed. So very good question. People actually get confused how to reach on to the individual Young's modulus. They think that what will be, it will be under root y1 y2, or it will be y1 by 2 or plus y, but it will be quite difficult if we don't approach in this way. People may reach answer, if they do not, they may mark this y1 plus y2. But if you solve systematically, if you solve with all the right concepts, you will be having this as the right answer, which we reached on. See, y1 plus y1 y2 upon y1 plus y2, no, this is incorrect. Under root y1 y2, that is also incorrect. I hope that, and please revise after the class also how to solve this question once again. That would be very much helpful for you all. After this, we'll switch to the next question. Just let me clear the board for you all. Let's go ahead with the next question of the day, the fifth question. If the ratio of lengths, radii and Young's moduli of steel and brass wires in the figure are A, B and C respectively. So ratio of length is A, ratio of radii is B, ratio of Young's modulus is C. That is what has been given respectively. Then the corresponding ratio of increase in their length would be corresponding ratio of increase in the length of steel and increase in length of brass. We need to identify what is the ratio. Given we have hanged here mass M, we have hanged here mass 2M. This is what that has been provided. Now you see here, given that, let's say steel wire has length L1 and brass wire has length L2. So let me mark here. Steel wire has length here L1. This has length L2. It's given that L1 by L2 is equal to A. Now it's given that radii, if it is R1, if it is R2, the ratio of radii is given as B, and their Young's modulus, if this is Y1, if this is Y2, that has been given as Y1 plus Y1 by Y2 equals to C. I hope that this first information you can easily understand, you can note down. For steel wire, I have taken length as L1. For brass wire, I have taken length as L2. Their ratio is given as A. For steel wire, we have taken radius as R1. For brass, we have taken radius as R2. Their ratio R1 by R2 is equal to B. Now, for Young's modulus, steel it is Y1. For brass, it is Y2. Their ratio Y1 plus Y1 by Y2, that is equal to C. So, if the ratio of length, radii, and Young's modulus of steel and brass are the ratio A, B, and C that we have already written down respectively, then the corresponding ratio of increase in their length would be. Again, we know the only formula that could be used here, that will be Young's modulus formula. So, if we write the Young's modulus formula, that will be y equals to F by A delta L by L. We need to find out what is the ratio of increase in their length. Delta L, if we write, that is equal to, if we make this a subject, that will come out to be FL by YA. Quite clear, FL by YA, that we can make out. So delta L of steel divided by delta L of brass is equal to, you see here, we need to write down in what ratio they are. F for steel upon F for brass. Now see, Young's modulus is the denominator, so we will be having Y of steel here and Y of brass here. Now you see we used F, we used Y, now L. L you see length is also given, so length of steel divided by length of brass. Area of cross section we have in denominator, so let me write down area and denominator. So area of steel divide, now here area of brass. This we will be writing as per the given information. I hope that you can see the entire equation. Quite lengthy, but now we have to only put up the values. Now force, that is the hanging part, that the load which is actually working on the steel. You see here force on steel, if you see here, that will be due to both this M and 2M. So that will be 3M in total. So let us mark here. I hope that you can clearly see up till this end. That is clear to you all. 3M and force due to on brass. On brass we have only 2M load that is hanging. 2M load. So put here 2M. I believe that you can clearly see it up till this end. Now Young's modulus of brass divided by Young's modulus of steel. That will be just inverse of this, that will be 1 by B, because brass is in the numerator, so 1 by B. Now length of steel upon length of brass, length of steel upon length of brass, that is A. Oh, just a minute, we have Young's modulus of brass upon Young's modulus of steel. We wrote here for the ratio of radii, that is actually equal to 1 by C. We need to write down 1 by C multiplied with length of steel upon length of brass, that is actually equal to A. So here you will be getting A. Now here you see area of brass upon area of steel. We have the radii, that is given as B. Now radii whole square, area is proportional to square of the radius. So we will be using square of the steel, square area of the steel upon area of brass, that will be equal to B square. So area of brass upon area of steel will be 1 upon B square. The terms that will be cancelled out M and M, so this comes out to be 3A upon 2B square C. 3A upon 2B square C. This is delta L upon steel and delta L for brass. 3A upon 2B square C. Let's check first option. 2AC by B square? No. 3A upon 2B square C? Yes. Option number B is the right answer. C, 3C by 2AB square? Incorrect. 2A square C by B, that is incorrect. The only option that is correct, 3A by 2B square C, that is correctly matching here. So I believe that you can understand how to solve such question that is given in this part. I believe that you have found it interesting and learning experience you will be having with all such practice of this first 5 questions. For the next 5 questions, I'll meet you in the next session. Till the time, do revise all these 5 questions. For the next 5, just wait for the next session. Let me catch you in the next session. Thank you everyone. Wish you all the very best.